We good actually.
Struggling.
Ah,
Speak for yourself,
Struggling.
Barack.
Okay. I have good
ah,
news for you guys. This is
yes.
the last theory, this last week of the embassism theory lecture. So next week, I will reserve the time for to explain, maybe revisit the parts you think it's very difficult for you to understand.
Yes,
So
please.
in the end of this lecture, please post the topic what you want I re-talk about, revisit the contents again. So just list it on our channel. And then I can prepare the slides in Friday or weekend, and then we can go visit those difficult parts again on the next week. Yeah, next week 10. So today is the final theory topic. So you are not going to learn any new things after this week. So the only one left is the assignment 4. So assignment 4 is really the very important, crucial assignment, because that is really talking about if you have understand everything we were talking about the embedded systems here, about the sensors, about activator, about communication protocol, and about the simultaneous tasks here. So try to spend time, understand the material, and post the questions. Try to finish the assignment 4 correctly. Yeah, this is going to have very heavy weighted to judge if you can pass this embedded system or not.
Miss,
Yes, Nicolas.
if we haven't passed 1 out of 4 assignments, is there still a possibility to pass the embedded system or not?
Oh, it depends on. That's I'm saying. The basis 4 is really important one.
Holy.
Yeah, it's a very important one. If you could do embedded 4, the assignment 4 very good, so I probably let you pass. That I have to align with other teachers as well.
Miss, for
Yes.
example, if you passed all the first 3 assignment but kind of failed on the fourth one, what will happen?
I will maybe give you some opportunity to repair it.
Okay.
Because I don't believe if you finish the assignment 3, you cannot finish assignment 4.
Yeah, I can understand. Yeah, because I
Because
feel like
3 and 4 more or less the same.
Yeah.
But 4 it's more structured. With additional communication, a little bit more complex than the assignment 3. So
yes.
it's actually assignment 3 is preparing to finish assignment 4.
There background.
Sorry, I cannot hear you. Okay, you can type the questions on the channel. Okay, this is again for the question hours for this week. It's a Friday. Yes. And this is our learning objectives today. Yeah, we try to recap the simultaneous tasks, and also we are going to learn our last sensor, more complex sensor for our embedded system orientation phase, and revisit the functions, and also like the states control flow chart, like functions states control flow chart. It's all helping you to think how to design your program, how to finish your assignment here. Will help you to do it. Yes. And in between, we will have a short break. So this is we are going to the agenda we are going to have for today. So I'm trying to go back to the last week's content about the simultaneous tasks. How do we program it? Yeah, because it's about we don't use delay. We use millis here. What is millis? Millis is I also made an additional video, like a couple of minutes video posted. I don't know if you have watched that video. So it's millis is really about a watch for Arduino. Yeah, it tells you about time information here. It's a I still remember somebody was asking me questions. Oh, I can use the timer or smartwatch to clock 2 minutes. Yeah, but here the point is you don't have timer. You don't have a smartphone. You only have a watch. How you are going to set up a timer for 2 minutes? How do you do it? So this is it's also always at this moment we see it's 10 minutes over 1 clock. So how you going to set the 2 minutes? How do you know it? So you check, okay, the starting point. Now you going to check every time, oh, it's my 2 minutes pass. If you 2 minutes pass, then you know, okay, your timer 2 minutes is pass. So in this way, so you have to really remember minutes, it's a watch. Arduino gives you the Arduino time information here. Yeah. So any questions on the millis? If you still think it's hard to understand the millis? No? Okay, then.
Miss?
Yes.
In the loop, how many minutes can you set up?
Oh.
Are there any limits?
No, you can see when the Arduino is power on, or maybe
Yes.
it's the millis start counting.
Yeah, I mean, you can set like current minutes for the LED, current minutes for the sensor, current minutes for whatever. Like, do you have limits for that?
No.
Okay, yeah.
Yeah, because only limits is one. It's counted because it's ticking. Our normal watch is ticking every 1 second, but here's every 1 milliseconds here. So in our normal watch is after 12 hours, then they restart counting again. But for our Arduino millis, it's after 49 days, actually after more than 4 billion ticking. Then this because you only have 32 bytes there, so 32 bits there. So in the end, it will overflow. It's just like reach the 12 hours. Then it's going to be overflow. Then it's restart from 0 again. Yeah.
Yep.
So if you power on your Arduino without the power off, then it will continue ticking until 49 days. Yes. So this is the way. So actually, the millis is Arduino gave you time information. So you can use this time information to scheduling to create your simultaneous tasks here. Yeah. So if you have questions, you can watch the video. I created a short video there, and then we can also discuss it offline. Here. About communication, Arduino, you and via the PC, actually, it's actually about you are writing the Visual Studio code. This is the Visual Studio parts here. And you should, both sides should use the same communication port here. And one thing you have to remember, if you are using, so the tips is when you are programmed with the Arduino side, you finish it, use the serial monitor print and debugging. If it's done, then you have to close that serial monitor, because if Visual Studio want to talk to Arduino here, if your serial monitor is open, the Visual Studio will give you error message here. It's the communication is only allow 1 instance per time. You cannot do the Arduino side cannot do multiple instances here. So it's here, when you finish debugging here in your Arduino side, always close your serial monitor. And here in the Visual Studio, you can communicate. You have to know this exactly same port number. Otherwise, they cannot communicate with each other. Yeah? Exactly same port number. So you have to know which port number is for the Arduino connected. So in the Visual Studio, you create port number, your serial port, use this port number to create your serial port. Yeah, this is the class I mentioned. You use it in the Visual Studio serial port. In our Arduino side, the class is called library is called serial. The time information here is called millis, this is time information, but in the Visual Studio, we have one class called timer. This timer, it's different than the millis. Millis is time information, but timer here is really the timer. It's about 10 milliseconds, 100 milliseconds, or 1 second to do the repetitive tasks again. So it means every 100 milliseconds, the Arduino here, they have events to check if there are anything from a serial port from this COM2 or COM4. And if anything is available, then they are going to print it out list on the list box or combo box here. In this way, you're doing the communication between Visual Studio and Arduino. Yes, questions? So, no more questions. Nice. Silent, okay? Okay, then just any questions? No, if we don't have questions, then I'm going to start our new theory lecture for today. So we have learned so far digital sensor, analog sensor, and digital actuator. And now we are going to learn a little bit more complex sensor and actuator. Actually, the one you already have used it's about display. Display is also, we call it a more complex actuator. Why is that? First of all, you all know about the digital analog input. What does it mean? Digital, we know it's about 0 or 1. So it means high or low, on and off, open or close, press or release. This means that means they only have 2 states here, or high or low. And on and off are 2 states, 2 value here. Analog input, they have continuously value here. It's from 0 to 1023. This is value like we have our temperature sensor, we have our light sensor, we have our potentiometers here. It's all analog input. So this is the potentiometer, temperature, and brightness here. It's about light sensor here. So this is you all have learned so far. And however, we are going to, because the...
Hello, excuse me.
Yeah.
But we have not learned the angle. I know it's like a map too.
Angle, it's the potentiometer, right? Yeah. So complex devices, yes?
On the same angle, does it mean that we can map not just temperatures and brightness, but also an angle? Like, where do you use it?
The angle is, I think, it's about potentiometer, especially for the example we are going to use in the assignment 4. It's about a headrest. That's about the angle, or maybe later on how you're going to make volume from from low to high volume, or you are using this one because it's the variable resistance, so you can change the value output. So you can also later on maybe control the dimmable LEDs. Or maybe
I saw through the assignment they are saying like the headrest should be, I think, up to 30, as in it shouldn't go beyond that. Does it mean that we should map it from 0 to 30, or?
Yeah, so yes, indeed, that's the point.
Okay.
And complex devices. So we see this is actually the word is not enough only about the simple devices here. So we have more complex sensors. Why we are saying they are complex sensors? Because they you read the data through their small serial I/O pins. So this small sensor, they have more intelligence, just like the potentiometer or LEDs. They have also small control units there, small, very, very small CPU there. Then they can control and build communication there. Yeah. So for example, like this one. This one we already used it, right? This is display on our reach shield here. Yeah, so you can see here, every digit here we have how many segments? I think 8 segments here. They have 1, 2, 3, 4, 5, 6, 7, and then this dot here. Yeah, if you say, okay, this is component I make it on and off, then I need 1 pin for it. Then and this I need 1 pin for it. So for what to display to control 1 digital here. So actually you need 8 pins here. It makes things more complex, make the draw is more complex here. So it's not good to design your LED display like every segment should has 1 pins there. If this is only 4 digits, later in our real life we have many big LED displays, then you have full of the pins there. That's just not manageable. Huh? So the scientists or electronics engineers, they think about a very smart way to do it. How do they do it? So they have extra IC. It's very smart IC. It's actually with the small control units. It's called your drive chip there. So, and here you only need 2 pins. So through here they have some software flashed in. So the 2 pins talk to the Arduino self. Then the Arduino can send a command to via a library. Here's drivers and a library, like we already create library to
Miss,
yes.
are you talking about the logical gates?
Yes. Yeah.
This seems like logical gate to me.
This is talk about. So let's do it. Yeah. So in actually in our calculator we have like so the states about enter the first digit, enter the second digit, no, enter the operator, enter second digit, then fourth one is a calculation, right? So every state will change from one to another one. They have certain criteria to, yes, certain action you need to trigger them from change from one state to another one. And also about the second assignment about the safe. So we have also have at least, I could think about is the 3 states there, right? If we talk about, it's about the safe close, safe open, and safe broken, these 3 main states there. And also like the car systems, how many states do you have?
If you are talking about the alarm, like there are 2 states of the alarm, and if you are talking about the light, there are also 2 states of no, I mean actually 3 states of light, and the headlight also have 2 states. So yeah, there are lots of states.
Yes, very good. So you the normal states, alarm states. Yeah, this is so. You also mentioned it about like we're talking about the lights. They have on and off or different states there. Very good. So actually, you already there are some seeds as already planted in your mind how to create these states here. So the first things I would like to just show you some terminology about the states. How do we draw it? You often see I use this signs to duplicate my states here. Like this is the states, or you can use this symbol as the states. And we all have the state like start states, and this is end states. And here's the transition, yeah, from one state to another state, the transition here. And for Arduino, often we don't see here, and we always say have the start states, initial states is about our default states. Yeah, this is a sign I often use it. For example, if we're talking about the traffic lights, a simple one, I'm not talking about the complex one. It's about like traffic lights. We have red lights and green and yellow. How these states can transfer from one to another. Here, this is a condition is about the time. If time is 2 seconds, then I'm going to from red to green. And then after 2 seconds, they transfer from green state to yellow. At the same, after 2 seconds, from yellow, or from red to yellow to red again. So this is an endless infinity state machine here. And here we can put additional one. For example, the initial states, I could put the initial states here. Maybe it's red or green or yellow. It's up to you to design which is the initial state is. Yeah. So you can see, actually, the states here is we are talking about a system level, and traffic lights here. I mean, system level. How many states here we have? And how do they change from one state to another state? And in this case, it's about time. It's about time. But this one, for example, and like Tianyu just said, oh, we have the car system. We could have 2 states. It's about the alarm and about normal states. Also, the lights could have states. Then we are talking about here the states. And normally we're talking about the system level, the product level. And of course, the component level, we could also have the states here. For example, here's about LED states here. LED states, it's low. Red LED states is low. And then the red states is high. How this state is going to be transferred in this toggle? Red LEDs, this application here, it's about button 1 is pressed, then you change the states from low to high. And from high to low is again, the button is pressed. So this is a component level. It's really about LED states. Yeah. So normally I was asking, hey, what's the states? It's about the system level. Component level, you also can do it. Also, you can put maybe replace about the button states. Button is pressed, button is released. Then how they are transferred from here. It's also states. So system, your product has states, and also component level, you have states. However, to help you to construct a program, the higher level, like system level, product level, will help you. And for example, here's like the safe, the state we were talking about is about safe close, safe open, and safe broken. And from this state change, what kind of condition, what kind of actions going to trigger this one state to another state? It's about look, safe, close, and if the passcode is okay and the room it's with the room lights, then safe will be open. And then from a safe open states go to safe closed states, it's you need dark lights for 2 seconds. That means the safe is going to be closed. And if from a safe closed to safe broken, it could be if flashlight, then I immediately give the warnings here, then go to the safe broken here. But of course, in our prototype, we want to go back to the safe closed states again. So if no flashlight, then the state's going back to here again. And here it's saying the initial state is safe closed here. Yeah. So in this way, you think about how your system level, your product level, the states change. So in this way, you put your code in your loop like safe close. Then you check if this is okay. Then you change these states to these states. In this way, you're going to construct your program. And later, I will show some pseudocode. You can know why I'm talking about here states again. Now, for example, I have the 3 states defined here. I can use this one. And later on, like, for example, temperature and time. I just, for your assignment 4 about nursing system, here is also how you do change the one of the normal operating states, but inside of a state, you have some sub-states here. It's about display time and display temperature. How do you switch from display time to display temperature? It's about press button left and press button left again. So it's toggle 1. So you press button 1 time, they change states from time to temperature display. And another time, and they back to the display time again. Yes? This is how you are going to construct your code, yeah, the pseudocode here, you have your states here, if states, and you do something here in the end, then you switch the states. And if in this short time states, you check it, do something here, then you change your states because the condition is triggered, condition is true, then you're going to be the states, change the states to short temperature states. So in this way, you just cycling around the states here, change the switch the states here. Yeah, this is actually very well said. It's about thinking in terms of states, give you a program design context. Yeah, how you're going to structure code. Its states is quite important here. And of course, the states are, like I mentioned before, we use enum, probably it's easy. And then, and here you use the if statements. Maybe it's better to use the switch case, then you can directly to see it, how the states transfer from one to another. This one, like here, you can compare. But of course, if you say I use this way, it's also fine. You pick up the way you think it's easy to understand to design your code. Yeah. States, yeah, switch states limitation here, and because here you have show temperature, show humidity, how you're going to construct it and break them. Yeah, this is a case does not define a scope. Declare an initialization variable in case is dangerous. Switch may escape the cases. So here, give you just an example how to program correctly. If you are going to put this local variable in this place, it might cause the problem. Your code won't work. So how you're going to do it? Probably you need move this definition before the switch cases here. Yeah, like here. You put the float temperature is before the switch case here. Yes. And that's it about the states. Any questions about the states? So when you start analyze your assignment, you have to first think about how many states your assignment a product has. Yeah, for example, the safe, you record it back, and from a calculator you can record back, and from a car system you can also record back. Then you think about for the assignment 4, how many states that alarm system has. So you have to think about it carefully and then construct the code in if statements or switch case statements and avoid these mistakes, then you'll be fine. Okay, any questions on state? No, then I'm going to talking about the flow chart and top-down design. So actually, in the assignment 2 and 4, you can see that we have the assessment criteria there. It's one about the boundaries, about you could maybe draw the states diagram, you could draw the flow chart there. It's yeah, it's not. For this semester, I haven't required you to do it, but if you can do it, it's always give you extra bonus there. So flow chart, it's about actually you have states now. Then how are you going to construct this code? So it's about the flow, like you are learning the. I think it's a your business orientation course. I forgot the name there. You have like the business flow chart, but here it's about the control flow chart, about your data flow chart. It's more or less similar. It's about the process, how it's going to from the data flow from one process to another process here. So actually, it really will help you to develop your code, also document your code. And so the top-down design is give you some idea how you're going to start doing your exercises, your assignment. You start with a general statement of solution, really the big part. You don't think about the small details. The big part, for example, nursing system, alarm situation, alarm mode, and normal mode. What should be? This is two big parts. And pick up one each time, then you start working, for example, alarm mode, what alarm mode should do, and should give sound, and should display on the C# application there, right? You should just think about how to do it. So you shouldn't worry about details at this moment. Just try to pick the big things, finish one by one. And of course, you draw the control flow chart. They also, this is simply simplified version. It's this is about the process, yeah, what should happen here, and here's about decision, which way you are going to, the Arduino is going to do. Here's the flow line, and this is the terminal or terminator here. Normally for the Arduino we don't use it. We always use these three, like the state machine. We always use a couple of them because the loop, we already decide this whole program is going to repeat again. For example, like I build a program switch lights on when the button is pressed. So this is about apply your business process flow. How you in this is building a program in the Arduino. How we do it? So we design our program, write the program, we test it, and check if it's correct. Then you're done. Your assignment's finished. If not, you're going to debug it and modify, write the program and test it again. So this is repeat. And after that, so your job is done, you submit in the canvas, you finish. And this is the flow. And for our flow chart for the Arduino here, it's like also you start, then you started set up, set up all the hardware and you need it, and then you write your code in the loop, put the code in the loop. Of course, the functions outside the loop, but in the loop you need call these functions here, and this is going to be repeated again. So this is the way you draw the control flow chart, and of course how you're going to do the, for example, the safe cases there, and you finish. This is always default. Then in the loop, what you are going to do, start it. Then you are going to check if it's safe open. And if safe open, yeah, I'm going to set password here. Then I'm going to do other things. If safe is closed, then I need to do the differently. I need to enter the password code here. Then continue. And enter password code is a function. So inside the function, you also have the flow chart again. You can enter password. How to do? Enter the. Check if the key is pressed. If the key is pressed, how many times is pressed, and then you check if another key is confirm key is pressed. If confirm this key is pressed, then you know the first number you already recorded. Input, keep it, and in this way, a couple of loops, you got the function here called enter password and set password. Then you are going to, for example, define the new password for a user. So it's the same way. You check the code, check if the button is pressed, how many times it's set, and more or less maybe the inside of this function and the inside of this function more or less may be the same. You have to try to find out how you're going to reuse the code again. And for example, design the program like here, loop here. You make the check if button is pressed and you set lights on. If not pressed, set lights off. This is going to be called a toggle here. So in the loop, you read the button input,